Hi, I'm Rye Guy, and we are going to talk about DHCP reservations and static IP addresses. Let's quickly touch on what a MAC address is because it's very important to what we are about to do. So a MAC address stands for Media Access Control. You'll normally hear it referred to as the burn-in address, the networking hardware address, my favorite, the physical address, the Ethernet hardware address. It's got a bunch of different names, but all a MAC address is a 12-digit hexadecimal number with numbers separated by 2 digits by a colon or a hyphen. Let's go ahead and take away our internet. Let's add in our router, our DHCP table, and let's add in our IP addresses. If you're coming over from our subnetting video, just remember that these IP addresses don't reflect a true subnet. This is only for our example. We also have some MAC addresses and a computer. I would like to make a note that your computer could have multiple networking connectivity devices, such as this computer could have two Ethernet ports, it could have an Ethernet port and a Wi-Fi, or however many different types of networking devices. Every single device that can connect to this DHCP server is going to have a MAC address, and this MAC address is what gets you your IP address. So let's go with computer 1 right here. Its MAC address is 2 Charlie 549188 Charlie 9 Echo 3. This bottom computer, its MAC address is 650136 Echo 8 9611. These computers are going to go up to our DHCP server and they are going to request IP addresses. Server says to Charlie, here goes your address, and 65, here goes your address. So now that these two have addresses, if you recall in our DHCP video that these are leases. So both of these computers have leased an address. In 12 hours, this lease is going to expire. So in 12 hours, this lease has expired, and it says, okay, for 2 Charlie, I'm going to give you the same address, and for 65, I'm going to give you this address, dot 3. And 12 hours go by, and then it assigns out new IP addresses. So the first computer goes to dot 4, the bottom computer goes to dot 2, and you can see where this would cause confusion if you want to have stability or a constant connection in your network. This is where IP reservations come in. So what happens to an IP reservation is that we log into the DHCP server, which is normally inside of your router, and we say, hello server, I would like this address to always be this IP address. Now I want to make a small disclaimer here. If you are playing around on your network right now, you will more than likely have to restart your router or your DHCP server to get it to spit out the new IP addresses. Either your computer will already have an IP address and it's not likely to be renewed anytime soon, or the IP address that you want to assign it might be assigned to a different machine. So let's just say that this computer is off and we have logged into our router, we have made the update, we have saved the change. We turn on computer 1. Computer 1 to Charlie says, hello DHCP server, I am to Charlie. And it reads the entire address and it says, I know who you are. Here goes the IP address that I have assigned to you. So this IP address will not be assigned out to anyone else on the network. So if 65 connects and all these other IP addresses are taken except for one, but this IP address .2 is reserved, then there's only one address for 11 to get. Now, depending on your router or your DHCP server, they might give a reserved address if there is no addresses left. So let's say in this scenario that your router somehow allows a DHCP server to assign that. So we have assigned all these IP addresses except for this one right here. And computer 3 gets turned on. It says, hello DHCP server, I am 65, I require an address. Some routers will say, sorry, you are denied access. because we do not have any allocated addresses. It could overflow the DHCP server, or it could just say, yeah, we've got one address left, here it goes. In other instances, it will only keep addresses for certain MAC addresses. In other cases, it will just dish it out. The key to take away from an IP reservation is that this server holds the key to giving that address. Your computer has nothing to do with that address. Next, we are going to talk about static IP addresses and how a client normally requests one. Now, a definition of a static IP address is just an IP address that does not change, which could be accomplished through our method that I just showed you, the DHCP. But when I talk about static IP address in this sense, it's when the client requests an IP address from the DHCP server. So 2Charlie goes up and says, hello DHCP, I am 2Charlie and I would like this address, .1.2. If this address is not already assigned, the DHCP server says, sure, here goes your address. Something happens when that address is already assigned. So computer 65 gets turned on for today, contacts the DHCP server, says, hello, I'd like an address. DHCP says, here goes .2. And then computer 2Charlie turns on, connects to the DHCP server, says, hello, I'm 2Charlie and I would like the .1.2 address. DHCP server is going to say, sorry, I do not have that, but here goes another address. So as you can see, when we are requesting IP addresses from the client side, we don't always get what we want. So that's why it's important when setting up a network to stick with the DHCP method as much as you can. You could go into a network where there is no DHCP and you have to manually assign all the IP addresses. I do not recommend that whatsoever for anyone just learning networking. Always use a DHCP server and always make your IP reservations so all your devices have a static IP address, and that will lessen the chance of you trying to get two devices with the same IP address.